So I wanted to say a little bit about rate of solution. All right. So far we've talked about this concept of solubility, and solubility literally talks about how much of a solute would be able to dissolve in a solvent. All right. But that says nothing about how fast the process of dissolving occurs. All right. So the thing is, there are some factors that will affect how fast this process occurs. All right. So an example that would illustrate the rate of solubility would be to think about sugar. All right. Sugar is incredibly soluble in water. All right. You can dissolve 211 grams in 100 milliliters of water. All right. Literally, you can get it to the point where there's more sugar than there is water. All right. But if you've ever taken a teaspoon of sugar and put it into iced tea, you realize that it doesn't happen quickly. All right. In fact, it can take a very long time for that sugar to finally dissolve in the tea. All right. But if you let it go long enough, it will eventually happen. All right. So in contrast, salt is not nearly as soluble in water as sugar. But if you add a pinch of salt to water, it actually dissolves fairly quickly. All right. So what affects this rate or the speed that things will dissolve? All right. So we first need to realize what is essentially going to affect this is recognizing the fact that when something dissolves, the solvent particles have to collide with the solute particles. All right. And they have to do this with enough force to dislodge them from their neighbors. All right. So picture this collection of molecules right here as being like a sugar cube, where these are the neighboring sugar molecules. All right. When that sugar is dissolving, these molecules have to collide with the solvent molecules, which in this case would be water, in order to dislodge the molecule from the neighboring solute particles that they're currently stuck to. All right. So if you've got a crystal of sugar, remember, all those sugar molecules are bound to each other. It's not a chemical bond, it's actually through hydrogen bonding, but still, they're going to naturally want to stick to each other. So for them to dissolve, something has got to dislodge them from their neighbors. All right. So anything that increases either the force that the solvent molecules are colliding with the solute particles will increase the solubility, or sorry, the rate of solution, or anything that increases the frequency of these collisions should speed up this rate. All right, so what are some things that affect that? The first thing is temperature. All right, so remember that temperature is a measure of the kinetic energy. All right, you can just think of it as the speed that the molecules are moving. All right, so if you heat up your solution, you're basically speeding up how fast the water molecules are moving around. All right, and so that's going to do two things. First of all, whenever the water does collide with one of these solute particles, it's going to do it with more force. All right, and that's going to help to dislodge these particles. That'll speed up the dissolving process. The other thing is that these collisions are going to become more frequent. The faster these water molecules are moving around, the more times it's going to collide. All right. So both of these would increase the rate of solution. So temperature is certainly a factor. All right. The hotter you make something, the faster things are going to dissolve. All right. The other thing, next thing is agitation. All right. Agitation is just a way of saying either shaking or stirring something. All right. And so essentially, what this does is this is going to increase the frequency of collisions between fresh solvent particles and solute particles. All right. So when you shake something, so if you just let something dissolve without stirring it, essentially when it dissolves, those dissolved solute particles will stay around the thing that's dissolving. All right. So like if you had a cube of sugar, you would have very sugary water right surrounding the cube. But the further away you go, it's going to be more like fresh water. So what the shaking does is it mixes things up, and some of that sugary water will spread apart, and that will allow fresh solvent to come in and collide with the sugar cube. All right. So that's why agitation will speed up the rate of dissolving. The last thing is going to be particle size. All right, so for example, powdered sugar is going to dissolve faster than granular sugar, even if you have like the same amount. All right, if you have 2 grams of powdered sugar versus 2 grams of granular sugar. All right, and the reason for this is that when you have granular sugar, the particles are bigger. All right, and so if we just kind of tried to diagram like what would granular sugar look like compared to powdered sugar. All right, well, this would be like, picture this being 1 crystal of granular sugar, where each of these cubes here would be a sugar molecule. All right, notice that the only part that can dissolve on this sugar cube is the part that is exposed to the solvent. All right, and that's going to be the outer layer. So if you had this 4 by 4 by 4 cube, there are going to be some sugar molecules in the center of this that are not exposed to the water molecules. All right, so what happens when we crush that? All right, so I didn't draw all of these, but you would have 4, you would end up having, I think this would be 1, 2, 3, 4, you would actually have 8 of these identical cubes that look like this right here. And notice that when you do this, each one of these, all of the cubes, all of the molecules would then be exposed to the water. All right. Of course, when you have powdered sugar, it doesn't literally mean that you have 4 molecules, but there's going to be a much higher percentage of those sugar molecules that are exposed to the solvent, and that's just going to make it so that the overall dissolving process happens faster. All right.